Hi everyone. If you want to see the best method to solve this question, you are in the right place. Now here, we are asked to calculate the blue area, that is clearly the summation of the areas of triangle ABD and triangle CDE. So blue area equal to area of triangle ABD plus area of triangle CDE. We have the length of this side to be 14 units. This side is also 14 units in length. The length of this side is 10 units. If we look at this segment AC, this line BD and this DE, they are congruent. So how can we solve this? How can we calculate the area of this triangle ABD and this triangle CDE? It is very simple. Since this segment AC, this BD and this DE are congruent, if we assume the length of this segment to be R, that of this segment and this each must also be R. Now let's focus on this triangle ABD. One of the formulas for calculating the area of a triangle is half AB sine C, where A and B are representing the length of two sides of the triangle, and angle C is the angle between the two sides. So here, if we let this side be A and this B, this angle must be angle C. Assume its size to be X. So A equal to R, B equal to 10 plus R, and C equal to X. Substitute those here. So area of triangle ABD equal to 1 over 2 times R times 10 plus R times sin X. 1 over 2 times R is 1 over 2R. 1 over 2R times 10 plus R is 5R plus 1 over 2R squared. So area of triangle ABD equal to 5R plus 1 over 2R squared sin X. We keep it aside. Come to this triangle CDE. We can also use the formula 1 over 2AB sin C on it. If we take this side as A and this B, this angle must be angle C. If you look at angle C and this X, they are lying on the same straight line. And we know the angle on a straight line is 180 degrees. So since this is X, this angle C must be equal to 180 degrees minus X. Now A equal to 10, B equal to R, and C equal to 180 minus X. Substitute them here. So area of triangle CDE equal to 1 over 2 times 10 times R times sin 180 degrees minus X. 1 over 2 times 10 is 5. 5 times R is 5R. This sin 180 degrees minus X. From trigonometry, there is an identity that sin 180 degrees minus theta equal to sin theta. So if we let theta equal to X, substitute it here. Sin 180 degrees minus X equal to sin X. That is, this sin 180 degrees minus X is sin X. So area of triangle CDE equal to 5R sin X. Recall here, area of triangle ABD is 5R plus 1 over 2R squared sin X. We substitute these values here. Now blue area equal to 5R plus 1 over 2R squared sin X plus 5R sin X. From here, 5R plus 1 over 2R squared sin X plus 5R sin X. We can see sin X is common. We factor it out. So blue area equal to sin X into bracket 5R plus 1 over 2R squared plus R. 5R plus 5R is 10R. So blue area equal to sin X open bracket 10R plus 1 over 2R squared. Now what are the values of X and R? We don't know. But if you come to this triangle, since you have the length of this side to be R, that of this side is 10 and this is 14 units. This angle which is facing it has its size to be 180 degrees minus X. We can use the cosine rule, by which in any triangle ABC, C squared equal to A squared plus B squared minus 2AB cos C. We know angle C is the angle facing side C. So if we let this be side C, this must be angle C. Assuming this is A, this must be B. So A equal to 10, B equal to R, C equal to 14, and angle C equal to 180 degrees minus X. Substitute it here. Now 14 squared equal to 10 squared plus R squared minus 2 times 10 times R cos 180 degrees minus X. 14 squared is 14 times 14, which is 196. 10 squared is 100. Minus 2 times 10 times R is minus 20R. Take the transpose of this 100. 196 minus 100 is 96. This cos 180 degrees minus X. From trigonometry, there is an identity that cos 180 degrees minus theta equal to minus cos theta. That is, this cos 180 degrees minus X is minus cos X. Minus 20R times minus cos X is plus 20R cos X. So 96 equal to R squared plus 20R cos X. We still need the value of X to proceed further. Come here, assume the size of this angle to be Y. Now this line AD, extend it to meet another line segment from this point B at an angle which will be equal with this Y. Label this point B. Now look at this triangle ABP. This angle and this angle are congruent. That is, the triangle is an isosceles triangle. The sides facing the congruent angles we know are equal. That is, this side and this. So since this is 14 units in length, the length of this side must also be 14 units. Come here, draw a line segment with this point P and this E as its end point. Here also, construct a line BC. Now look at this quadrilateral BCEP. We have this BP and this side CE to be equal in length. And we see this diagonal CP bisect this diagonal BE. There are two types of in which a diagonal bisect the other. That is, a kite and a parallelogram. A rectangle and a square fall under parallelogram. But here, a pair of opposite sides are congruent. In a kite, no pair of opposite sides are equal. Therefore, this quadrilateral is not a kite-shaped quadrilateral, but a parallelogram. So the quadrilateral is a parallelogram. In a parallelogram, opposite sides are parallel and equal. That is, as much as this side and this side are equal, they are also parallel. We see this line CP intersect both. Therefore, the angles formed are alternate equal angles. Since this is Y, this angle must also be Y. Now come here. Since the length of this segment is R, we draw from this point a line to a point on this line DP, R units away from this point D. Look at this triangle. Two of its sides are equal in length. That is, it is an isosceles triangle. The angles facing the congruent sides are equal. That is, this and this. So if we let this be Z, this must also be Z. If you come here, this angle X and this are formed by two straight lines intersecting. That is, they are vertically opposite angles. Vertically opposite angles are equal. So since this is X, this must also be X. Now look at this triangle ABD. The length of this side is 14 units, and that of this side is the summation of this R and this 10. So it's 10 plus R. This angle between the two sides has its size to be Y. The same is for this triangle. The length of this side is 14 units, while that of this side is the sum of this 10 and this R, which is 10 plus R. And this angle between them is also Y. that fulfills one of the conditions for the congruency of two triangles SAS. So the two triangles are congruent. Therefore, since this side has its length to be r, the length of this side must also be r. Now look at this triangle. All its sides are equal in length. That is, it is an equilateral triangle. All the three angles of an equilateral triangle are 60 degrees. Therefore, this x will also be equal to 60 degrees. Substitute it here. Now 96 equal to r squared plus 20r cos 60 degrees. Cos 60 degrees is 1 over 2. 20r times 1 over 2 is 10r. Bring this 96 to the right. So 0 equal to r squared plus 10r minus 96. Here 10r is the same as 16r minus 6r. From r squared plus 16r we factor out r. So it is r into bracket r plus 16. Here minus 6r minus 96. Factor out minus 6. So it is minus 6 into bracket r plus 16. From r into bracket r plus 16 minus 6 into bracket r plus 16. R plus 16 is common. We factor it out. So it is r plus 16 times r minus 16 equal to 0. That is r plus 16 equal to 0 or r minus 6 equal to 0. Make r the subject of the formula. So r equal to minus 16 or r equal to 6. Which of this is the right answer? R is the length of this side. It can't be a negative number. Therefore, r plus 6 is the right value. Now we have r equal to 6 and x equal to 60 degrees. Substitute them here. Sin 60 degrees is 1 over 2 root 3. 10 times 6 is 60. 60 squared is 36. 1 over 2 times 36 is 18. 60 plus 18 is 78. 1 over 2 root 3 times 78 is 39 root 3. So blue area equal to 39 root 3. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.